And we head into the final question on the Exponents and Surds test of 2020. And remember, the key of what we're trying to work with here is not, oh, here we go, so you solve this and do, but how do we know what to do? And then what do we do with that? And let's see if we can link it with the previous questions. So let's ask one of the questions that I ask again and again and again. How many terms do you have in the numerator? Well, it's the same as the terms in the denominator, and the crucial thing here is that we don't have one term over one term. So that's one of the questions we ask, and the other question is, okay, what about these numbers here? This is 9 to the x, 9. Is everything a nice prime number? Prime base, I should say. Is everything a nice prime base? Well, it's not. So let's see if we can combine those two ideas and say, well, we've seen these types of things before up here where we said, oh, like a 9, well, we changed that to 3 squared. Oh, we had this idea of, taking out common factors, this idea of factorizing. Maybe if we had like a summing to the 2x and a summing to the x, then maybe we'll do like a k method type thing. So let's see what we've got here. So first of all, let's maybe make this into prime bases and see where that gets us. So we've got this as a prime base, 3 squared to the x, so 3 to the 2x, minus 3 squared. And on the bottom we've got 3 to the x minus 3. They look so close, the numerator and the denominator. You just want to start cancelling something, and you're going, well, it's like marshmallows. But you can't cancel like that, but it's feeling close. And I get that feeling thinking, sure, must be something I can do. So the other thing we talked about was, factorizing. Well, in the denominator, what can we do? What can we do to factorize that? And I was going to say it's a trick question, but it's not a trick question. It's just one of those questions that we think, well, all we can really do is take out a 1, or basically put it in brackets. Looks like there's a 3, but remember this is 3 to the power of 1, so you can't take out a 3 to the x and you can't take out a 3 to the 1, so let's just put it in brackets. But the top, sure, the top there's something. Now, this is definitely one of those maybe, oh, now you see it or now you don't. Last time we said something like, oh, well, a 3 to the x, or it was 2 to the x or whatever it was, we let equal k. So we used that strategy to say, well, let k equal 3 to the x. Well, then 3 to the 2x, what is that in terms of k? Well, that's k squared if we compared with what we did earlier and said, well, 2 to the 2x was the same. Here we go. Let k equal 2 to the x. So 2 to the 2x was k squared. So that same idea in this question to go, well, it's like it's k squared minus 3 squared. That looks like a difference of 2 squares. No, just don't, right? Okay, so, but we've got a difference of 2 squares. That's what's hiding in all of this. In this thing here, we're saying there's a difference of 2 squares, which we know we factorize difference of 2 squares, bracket, 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 bracket. Now, the bottom piece of bubble gum here is, where was our bubble? 3 to the x minus 3. So that's still there. Now, we're hoping something's going to cancel, so maybe one of the brackets will end up being identical. Well, let's see. What times what gives you 3 squared? Well, 3 times 3, and we know we go plus minus. Now, if k squared equals 3 to the 2x, then this would be k squared minus 3 squared, or k squared minus 9. So it would have been k and k. But we can skip that k version and just go, well, this is 3 to the x and 3 to the x, because bases are the same, we're going to add exponents. But remember, coming back to, what are we trying to do here? Not, oh, well, that's how you do it. Okay, well, I could have read the memo. How did we get there? We saw 2 terms over 2 terms, or 2 terms over 1 term, but we saw that there were multiple terms, so it made us start thinking maybe we can do some sort of factorizing so that we can have 1 term over 1 term, because once we have 1 term over 1 term, then we can start cancelling and simplifying. So we do that by going, well, nothing jumps out. There's no common factor. There's no difference of two squares. It's not a trinomial. Okay, well, let's change this to prime bases because that's so often what we do. So let's do prime bases. I feel like I hope I haven't got the volume too loud. I love these last questions because they're really just tying in what we're doing. And in this case, it's so beautiful for what we're trying to achieve. Okay, so what happens is, great, that whole bracket is the same as that whole bracket, and we're left with just that bit there, right? 3 to the x plus 3. But how we solve it? Okay, so let's see if we can use a similar idea in this last question. So we're looking right above here, right? And we're seeing, now let's get me back. I don't actually have the preview in front of me. Just testing out the features always. So we got multiple terms over multiple terms. Maybe I should ask it, how many terms do we have? Okay, right? So the point is, we don't just have one term of one term. It says without a calculator. So as much as you quickly run away and get your calculator, even if you type this whole thing in and you get your answer, it's not even getting you any marks. It's not showing your thinking. It's not helping at all. So let's see how we can turn each of these into one term. Now, the bottom. What can we do to the bottom? And why is it not a difference of two squares? And the highest common factor is interesting. So what can we do to our denominator? Well, we can't really do much except go, let's put some brackets around it. I always think that's a nice little cheat or cheap way to turn it into one term. Well, that was easy. What about the top? Now, the top looks like it's close to a trinomial. So it looks like maybe it's one of those k-squared type ideas. But let's just see. So if we let k, because that's not a bad way of thinking, let k equal 5 to the 2004 and go, oh, okay, well, maybe this is like k squared minus k plus 24. Cool, we can factorize and go from there. Maybe it's a 8, or who knows. But in that case, what would k squared be? Well, it would be 5 to the 2004 squared. Excuse me, we're going, what's all to show? This is it, this is the real thing. Oh, I guess I could pause or something. But, so if we squared that, power to a power, you multiply them, so that would be k to the 4008. Okay, so it's not going to work to go, oh, so it looks like k squared minus k or something like that. But if you're thinking along those lines, it's a nice way to think as well, because that could easily have been the case, and maybe you will get a question like 5 to the 4008 minus 5 to the 2004. It's an idea. So bank it if you've got that idea. If you didn't, now you do. So what to do? What does it look like should hopefully cancel somewhere along the way? Well, hopefully the question's constructed that, hey, maybe this cancels with something on the top. So maybe there's a 5 to the 2004 plus 1 hiding somewhere in there. Well, there's a 2004 there, and there's a 2004 there. Now here there's no 5 to the anything. So here's my hint. The hints are, we thought maybe it was trinomial. Well, it is a trinomial, but we thought maybe it was like a quadratic with a squared. But we checked that and that didn't work. So we bailed on that idea, but we liked it. We're still thinking we're going to have to factorize so we can do something. So we're going, okay, now let's group this and say that those two go together. Still looks the same. Is there something common? What's the highest common factor between those two terms? Highest common factor I see is 5 to the 2004. Now this is looking good because it looks like something's brewing. So we're going to do that, and then this plus 24 we could leave on the outside and just leave it there for now. Let's see where it takes us. And this is the idea. I mean, this is the last question of a test. So we are just playing and this is why you need to have a little bit of extra time here to just allow yourself to pause. This isn't a standard question. Okay, so 5 to the 2004 times what gives you 5 to the 2006? What should our base definitely be? Our base is definitely 5 because the bases are the same, so therefore we can add exponents and we get a 5 squared. And this next part is minus 1 because well, that's 1 times that gives you that. Okay. And from there, whenever you see something in brackets, maybe you go, let's just simplify. So we've really solved and cracked the question by going from that to that. That's the hard part of the question because, as you'll see now, well, 5 to the 2004, well, 5 squared is 25, 25 minus 1, well, that's times 24, plus, let's put this in that, maybe that gold, and go, okay, 5 to the 2004 plus 1, and now it jumps out at you, right? Does it jump out at you? What you do now, we still want to turn the numerator, this one here was already 1 term. We still want to do some magic to get the numerator to 1 term, so what can we do? Well, I see a highest common factor staring at us there, so if we take that 24 out, what are we left with on the top? 2004 in the numerator plus 1, which conveniently cancels with that thing there and we get 24. So key part of the question was, let's try and get it to 1 term of 1 term. That seemed to work quite well and we got there eventually. Okay, so that's some thinking into how to approach questions like those where we're using all our skills from these types of questions which are more straightforward. I was going to say basic, straightforward. They're more straightforward and there's a method and a strategy and we're getting comfortable with those, seeing which one to use, and then zing, 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 this is going up and down way too quickly, and we can say, well, great stuff, we get there. Now, I realize I've probably been in the way, and so I thought I should have had, that's why I have that feature, right? What do you think? Isn't that a cool feature? I can be like, well, look at it like over there, but now let's go and check it out over there, and we should just finish the video. Hey, so goodbye. Oh, hello.